So here we are. So again, thank you. First of all, timing of this webinar. We are aiming to do this in a short and very structured way in 1 hour. We have a lot of participants, so we hope that we are able to manage this, but that will be normally no problem. So we're going to do this in 1 hour. I will speak for 40-45 minutes to leave some room for questions and answers, and know that everybody who has questions, afterwards, that we are there to help solving them or giving answers to those questions in an individual meeting afterwards or by some communication by mail. So first of all, just one slide about who we are. You're following a webinar of Netalux. It's always a fantastic opportunity to say what's in a name. Neta is Esperanto for clean, net, precise, and lux is the Latin word for light, so the cleaning light. We're quite unique in what we do, since we offer everything that has to do regarding laser cleaning. So as the slide mentions, we provide a complete ecosystem in laser cleaning solutions in order to reduce the threshold to implement it and to stimulate its widespread adoption. That's our mission. We started off as a contractor company, which is called now Netalux Experience. It's a business unit where we perform services as well as at the clients as at our own workshop. That's how we started off. And then due to the experience that we gained, the applicational know-how, we decided to become a machine manufacturer, to build our own laser cleaning machines, as well mobile as stationary, and to have that Netalux product business unit. In that Netalux product business unit, we sell equipment, but we also rent it and everything that goes in between with that, even offering a Netalux machine in an as-a-service approach, so that we do the investment of the machine and we send invoices every time the machine is used. And to build the bridge between that experience branch and the product branch, we have the Netalux Academy, where we train people worldwide in what laser cleaning can do for them, what the applicational know-how is that they need. So providing those 3 business units, we claim to have the complete ecosystem in laser cleaning solutions worldwide. This webinar goes specifically about the laser cleaning in tanks. So there are some different chapters here. We have some challenges to overcome if you want to do that. We also give the answer to our solution to those challenges. And then the most important part of the presentation, we have a very short case about product residue, and then a more detailed case about the removal of flash rust in a very big tank in the petrochemistry industry. Then we conclude by giving the advantages, different advantages of laser cleaning when you compare it to other technology. And then there's a last chapter regarding the financials about a project like this. But first of all, the challenges to overcome. But there are a few challenges that you have to overcome if you want to implement laser cleaning in a real practical situation. First one is the fear of the unknown. A second one is a question that we always get: does the laser damage the metal? A third one is regarding logistics. A fourth one is also a question that we get every time: ATEX, explosive environments, is it applicable, yes or no? The weather conditions, toxic residues that may be still in the tank, productivity. What about productivity? Is it fast? Is it not fast? And last but not less important, questions about safety. First of all, the hardest challenge to overcome is the fear of the unknown. Despite the fact that laser cleaning already exists since the 70s, and that's a true statement what I do here, about it existed since the 70s, the fear of the unknown is still the hardest challenge to overcome. The only answer that we can give there is thanks to our unique combination of business units and first-hand laser experience. You can rely on us and on a multitude of reference cases with customers as Dow, Vinova, Huntsman, Johnson & Johnson, Perna, Sudal, and many others. to help you to overcome those challenges. I've seen that the audience is quite a big group, but an interesting group. There are contractors interested in starting up laser cleaning services. There are contractors already invested in laser cleaning machines. There are asset owners. There are quality assurance inspectors. So it's a very interesting group to try to help us to use laser cleaning in a more broader aspect. But the fear of the unknown is that one thing that you will have to overcome without any question. Then secondly, the question, as I referred to, that we always get, do you damage the metal? The answer is no. That's the only correct answer. An answer that goes underneath is no, when you apply it correctly. As some of you may know, others maybe don't, there are two types of laser shapes that you can use to laser clean. One of them are the Gaussian lasers, and the other ones are the top hat lasers. In tank cleaning, in 90% of the cases, we use the top hat laser, which has the capacity to not damage the metal. However, if you don't apply it correctly, damage, whatever the definition of damage may be, is possible. But if you set the parameters correctly, it is strictly impossible to damage the tank interior or the metal while using it to clean a tank. Logistics, something people are also quite often ask us: can you decouple the handheld from the base unit? The answer is no, it's impossible. Base unit and handheld are one. With those top hat lasers to clean tanks, the fiber length is quite long. You have 50 meters of fiber, so you have a lot of range that you can get to with the laser cleaning devices. But the base unit and the handheld still are one. There are machines available on the market as from 200 and 250 kilograms. There are other ones who goes up to a ton. The weight is something that you have to encounter. Nevertheless, even if it weighs 250, you can't carry it with operators. So you would have to need some lifting devices, forklifts or cranes to manipulate your equipment to get it on place. Dimensions of the equipment, you can compare it to an electricity generator. So you can easily put it into place. That's not an issue. And in our case, the machines are always built to be lifted, as well as with forklift or with a crane. So there are some logistics challenges that you have to encounter. Then the second most asked question regarding explosive environments. There are two things that you have to see in that situation. There are the base unit and the handheld versus the application as such. So first of all, the base unit and the handheld. Today, our machines, and I think also those of the competitors of ours, are not ATEX proof. To make them ATEX proof, it's not hyper complicated. It's always feasible to do something like that. But the second thing, the application as such stays what it is. You're always putting energy into a system. As we use laser cleaning, we use the energy of the infrared light to clean a surface. And that depends on which type of laser that you use, but it goes from 1 millijoule to 150 millijoule per pulse, and you shoot thousands of pulses per second. So there's always energy in that atmosphere. Nevertheless, you don't need oxygen in the room to be able to function in laser cleaning. So if there's a real bigger issue, then you could replace the oxygen by an inert gas to apply your laser cleaning. What we always do is a very good risk assessment. And based on that risk assessment, up until now, we did every job, also in ATEX environments. More on that in the safety part. But the most important thing is that you put LEL detection systems, lower explosive limit detection systems, as well as for equipment, as for the operators. Weather conditions, it's applicable in most outdoor situations. The only thing that you should consider is extreme heat, extreme cold, and humidity. When it's raining like it's doing today in Belgium, then we have some issues, and then you need to put some tent construction or scaffolding with some plastic wrap around it to keep the machines dry. But in most of the outdoor situations, it is not a problem. Another challenge are the toxic residues. And in many cases, residues can be toxic. And as laser cleaning creates gases and or aerosols, yeah, it can be potentially harmful for operator and environment. So you would need appropriate fume extraction using industrial vacuum cleaners with correct filters. Correct filters meaning that you would have to use a pre-filter, and for laser cleaning, in any case, a HEPA filter that goes afterwards, as you create a lot of very small particles. And in some cases, based on the contaminant that you are removing, maybe you would also need some active carbon filter afterwards, after the HEPA filter, and maybe even some gas washing. That last thing we never did until so far, but active carbon, we definitely used it in some applications to be 100% sure that all of the residue was cleaned afterwards. If you work with toxic residues, you would also need clean air for your operators, breathing air, to help them to work in a safe way. Be aware that toxic residues can always be hidden in the pores of a metal. We have a reference case, which is obviously confidential, but we have a reference case at a very big client in petrochemistry, where we cleaned a tank, or we removed the flash rust from a certain part of the tank to be able to grind and to weld. And the asset owner assured us that there was no residue of the product on the metal anymore, as they have taken some wipes and did some controls. But nevertheless, the laser, after 30 minutes, it was very clear that it removed a lot of toxic residue from the pores of the metal. So it's an advantage that laser cleaning have. You clean into depth, but you should be aware of that, and always ask for a material safety data sheet if you clean something using laser cleaning. Regarding productivity, we always talk about net productivity. Maybe I'm going to say I'm going to compare it a little bit stupid or too simple, but we only calculate when the light is coming out of the system. It's very easy to say that a technology can have 10 or 15 square meters an hour, but if you have to clean up afterwards, if you have to fill something again, if you can only do it for 30 seconds and then you have to wait for pressure to build up again, we are talking about a net productivity that you can achieve. And in most of the tank cleaning cases, is above 5 square meters an hour, depending on the situation. And taking into account that in this webinar, we always talk about handheld systems. So it are always operators performing the job. In the future, we are definitely looking into automation of those systems to be able to offer that for our clients that buy our machines, so that tanks can be cleaned in an automatic way. And then the last part in this introduction regarding safety, you should always obviously make a specific risk assessment at all times. But the general conclusion is that it's safer than other technologies. People are always afraid of the laser light, but even if you work with 3000 or 2000 bar of high pressure water, you cannot go into the line of fire. For a laser, that's the same thing, and it's immediately switched off if you loosen the button on the handheld system. The safety guard should always be at the manhole or at the entrance of the tank, but that's more regarding general safety. And also because in most of the cases we work under the condition of a hot work permit, knowing the energy that we use, thermal reaction using energy. We always set up a parameter to have a safe working environment. You should always work obviously with trained operators. And in the aspect of a tank cleaning, the environment is already closed. so the setting the parameter there is quite easy because you only have to watch out for the manhole. And then what I already mentioned in the chapter about toxic residues, you should always ask for a material safety data sheet of the removed or the to be removed product. That is very important. So going to the cases that we have here in the presentation. A first one is a short one, a short case, small tank. In the chemical industry. In this case, it's a silicone residue that has to be removed. And that product residue has to be removed because the buffer tank is going to be used for another product. And so they use the buffer tank for different products in their process. So here, operational setup should be well prepared, as in any case, obviously. And we do this kind of treatments or laser cleaning for the smaller tanks going from, let's say, 8 square meters to a little bit above 25 square meters. Mostly those are tanks with a certain diameter where the height is bigger than the diameter. And we have to watch out for operator ergonomics. So what we do is we put, mostly it's the client, we put, I see that you guys are getting a poll. I'm going to shut that down because otherwise I can't read anymore. The operator ergonomics, we put a sort of platform in the tank, and we always work in any case, in any tank cleaning, top downwards. So using that platform, we first of all clean the above part of the tank, and then we go downwards. We remove the platform out of the tank, and we clean the sidewalls on the bottom and the bottom of the tank itself. Previously, in this specific case, they cleaned with high pressure water or dry ice. The problem for them, or the challenge for them using high pressure water, is that the film layer of silicones that stays behind on the tank wall is in a sort of way elastic, and the high pressure water, being a mechanical technique, has a sort of, I always call it bounce back effect. I don't know if that's an official term, but it has a certain bounce back effect on the film layer of the silicones. And when they use dry ice, it goes better, but they still have some bounce back effect, and they have a lot of air movement and noise in their production facility or their production area. And that's something that they do not want anymore. So what we do with the laser cleaning is always based on reflection and absorption. So first of all, the laser has to be able to reflect on a substrate, most of the cases metals, and then the contaminant that's on that layer is absorbing the energy. In this case, what will happen is that the film layer of silicone, as you can hopefully see it on the above part of the picture, the residue, the film layer, is going to absorb that energy, creating some fumes and some vapor, quite invisible for the eye. But the film layer will shrink, and the vapor layer will come between the contaminant and the metal layer, expanding and pushing the film layer away from the metal surface. Meaning that you are cleaning that tank without any air movement, without any waste, and without any noise. And so we brought back, for this particular customer, we brought back the cleaning cycle from 3 to 4 working days. We brought it back to 1 working day. So you're immediately in the economic line of interest. And that's why we always did that for them since 2 or 3 years. Then a second case, and a little bit going more into detail about the project. So flash rust description in general: after high pressure or ultra high pressure water cleaning, a flash rust layer occurs very quickly, as you all know. That flash rust can act as a catalyst for a chain reaction. For example, in the case of EO, or ethylene oxide, oxides act as a catalyst to create a chain reaction to create polymers. So there cannot be any oxides or any flash rust. Or in another case, a flash rust can act as a contaminant for the product. In both cases, it's a problem for the process that they have. Previously, this flash rust was cleaned with or grid blasting or sponge blasting. The problem is that it's time sensitive. Why time sensitive? Because when you start in a big tank and you start grid blasting, when you reach the end, the first part that you did is already rusting again. With laser cleaning, as we mentioned before, we really clean into depth, really into the pores of a material, so that all the salts, chlorides, imperfections are coming out. Grid blasting or sponge blasting gives a very nice visual result, but it's not clean up until the pores of the metal. So the oxidation process or the rust process will start very soon after the grid blasting. So time sensitive. They're under an enormous time pressure to close up the tank or to put the tank under nitrogen conditions. Secondly, you have to build a containment, because the grid, the sponges, they will be everywhere, and you will have to concentrate them and evacuate them as waste. And so you have to be able to build a containment. And then thirdly, what I already mentioned, mentioning the containment, is the waste, obviously. So all the waste has to be gone afterwards, and that's also related to a cost. And what asset owners from time to time tell me is that, yeah, we have grid blasted that tank 2 years ago, and we still find the grid, or the grid went into air suspension, flew around in the surroundings of the tank, and now we have damage there, or rust incidents around the tank. So this is what they did previously. In this specific case, which I'm going to describe, we're talking about a tank on a petrochemical site with the storage of a liquid chemical product. And the tank dimensions are a diameter of 12.5 meters and a height of 12.5 meters. The tank walls and the floor need to be cleaned, meaning that we have to clean 613.6 square meters. Our operational setup is that for this case, we used two 1000 watt mobile laser cleaning machines in parallel. For each machine, we used two industrial vacuum cleaners, also in parallel, obviously, and that we had 2 operators per machine, meaning 4 operators in total in the tank. As you can see here on the scheme, which is fiction, of course, it was illustrated here at Netalux. It's not a real situation, but it gives you an idea about the tank and the operational setup. So we arrived, and then coming back to the different types of challenges that you have to overcome. So everything where the tanks are and where the machines are is an ATEX environment. You see that coming from the trucks, there is no free entrance for the machines to roll them in. So we needed a crane to put the 2 machines on site. To encounter potential bad weather conditions, scaffolding was placed outside the tank using a plastic foil to wrap it up as a sort of a tent, and the machines were stored into that. Then the vacuum hoses from the industrial vacuum cleaner and the fiber for the laser, a 50-meter fiber range, were entered in the tank by the manhole. And for your information, the breathing unit, so the breathable air unit, was placed where the trucks are seen at the bottom right corner of the illustration, because that was a non-ATEX zone. So also those cables were with a certain distance moved to enter by the manhole. So that is basically the situation as we had it there. LEL explosive meters were placed on the electricity distribution systems of the machine. So if there was an alarm, the machines were automatically switched off. And there was a safety guard next to the manhole who had an external safety stop for the both of the machines. And he had also some measurement equipment for the tank to always clear the area for our operators. So basically, that was the situation. So in general, like we said, with the product residue, operational setup should be very well prepared. We already did this from tanks from 50 square meters to more than 600 square meters. So the tank that we showed on the illustration was by far the biggest one that we did up until so far. And the interior of the tank was scaffolded. There was a scaffolding completely surrounding the tank for the tank walls, to clean the tank walls. And we did this in parallel with multiple machines. We also analyzed the possibility to do this with 3 machines in parallel, but depended on the risk assessment of the customer, it was chosen to only work with 2 machines in parallel, because then we already had 4 operators inside the tank. And in case of an emergency, in case of an alarm, in case of an accident, they all had to be able to take them out in a certain period of time. And that's why we limited it up until 4 operators here. On the other hand, in general, you can also clean multiple tanks in parallel. We will start as from next Tuesday. We will start in the Netherlands with 3 tanks in parallel. That is obviously also a possibility. You need a safe environment, as we described for the base unit. You would need LEL measurements both on the equipment and on the operators themselves. Every operator carried a LEL explosive meter. And as I mentioned, we used it with 2 operators per machine. And for ergonomic means, we also installed a sort of a support system to attach balancers to the laser handhelds. So the ergonomics of the operator were taken into account in using that way. So what did we do? The 30th of March this year, we installed all machinery. So we took one complete working day to install the machinery, delivery of 2 machines, the vacuum cleaners, also the compressors, because to use high power machines, most of the manufacturers, as well as we attach a compressor, a simple compressor with 350, 400 liters per minute and something like 3.5 bars of air pressure. We attach them to the laser cleaning device. Why? For 2 reasons. One is an extra cooling for the laser head, so that fresh air circulates in the optics and the laser head. And secondly, then you keep your lenses more clean. There is a sort of airflow. It's not really an air knife, but a sort of airflow coming out of the optics, which keeps most of the dust and the particles away from the lens. Because when you laser clean, you should always try to keep that as clean as possible. Because otherwise, if your lens or your safety glass contaminates, then the energy can't go out anymore, and your safety glass or in worst case scenario, your lens will break, and you would have to replace it. All those things, machinery, vacuum cleaners, compressors, were installed on the 30th of March, and then we started on Wednesday. We started to laser clean the tank walls, and we did that until the 3rd of April. And then there was some national holidays here in Belgium, so we started again on the 6th to continue the laser cleaning of the tank walls. So the tank walls were all cleaned in 8 working days, and a working day in this case was a shift of 11 hours. So we always started at 6:30 in the morning, and we worked until 11:30 in the evening. We had a combination based on the risk assessment and the availability of safety guards. We always had 4 shifts inside the tank, each time a shift of 2 hours. So at 6:30 we arrived, we switched on the machines, everybody got ready, put the breathing air on, the paper overall, and then they entered the tank for 2 hours. After 2 hours they came out and they had a break of 30 minutes. After that break of 30 minutes, again a tank entrance of 2 hours, then a large break of 1 hour, to be able for them to eat, to rest, and then again 2 hours, half an hour, 2 hours, and then some time to leave the working place as neat and clean as possible. Then after the tank walls, obviously the scaffolding has to come out. So the scaffolding removal was done in 1 week, in 5 working days, by the contractor of the scaffolding. Everything was taken out. And then on Monday, the 19th, we started laser cleaning the floor. And we had 2 days, we needed 2 days to clean up the floor. And then on the 21st of April, the removal of all machinery was done. So in summary, 1 day for installation of machinery, 1 day for removal of machinery. And we had 10 laser cleaning days to clean the entire 613 square meters. The efficiency that we gained, if we take into account the hours that the lasers turned, we had some hiccups on the site, but if we calculate it in a correct way, we had a net efficiency of more than 5 square meters an hour. Again, I like to stress out, manually, handheld, the operators did it by hand, not automated. If you think about automation, you should easily be able to double that net efficiency. We had some, in all transparency, some encountered challenges. We had some compressor failure, so we had to switch, replace a compressor. The electricity feed, that's an important one. The systems work, the high power systems work on a 3-phase system, 380 volts. And we had some problems with the electricity that came in. And the systems that we built are in fact computers. We built a computer platform to operate our laser cleaning devices, and also to be ready for Industry 4.0, machine learning, and everything that comes with it. So we monitor very closely and very detailed everything that comes in, and if it's not correct, then the systems are not able to switch on. So we had some problems there. So that's something that we always have to check with our asset owners in a very detailed way in the future. We had an extreme variety of weather, but really an extreme, typical Belgian weather. So we had storm, we had snow, we had rain, a lot of rain. We had sunny days of 23 degrees, so it was amazing. But at a certain point during a weekend, there was that much rain that the whole area where the machines were located I don't know the exact word, but became underwater. It was completely underwater. So the machines, the bottom of the machines were completely underwater without damage. That was the luck that we had. And we also had false level measurements in the breathable air supply. So every time that we had that, everybody had to come out of the tank. Obviously, that's normal. But afterwards, it were false alarms. So that was difficult. And what we also had in the tank was a bad high pressure water preparation. So the tank was buttered, and at some areas it wasn't done correctly. So there we were a lot slower than 5 square meters an hour because there was a lot of residue that stayed on the tank. So that was the case description of a bigger tank in petrochemistry. To summarize the advantages that laser cleaning, in our opinion, has when you compare it to other technologies is that you have no need for confinement. There is no air movement whatsoever when you do it. The result is very, very clean. It's a very clean net result. There's less time pressure to close the tank. We also saw it using, in this case, when the scaffolding took, you have the 2 weekend days 2 times, it's 4 days, and then 5 days to remove the scaffolding. It was 9 days between the last piece that was laser cleaned and we entered again. And then you saw that it was still very clean. General safety is, in our opinion, definitely an advantage. There are no residues besides the primary residue. So the residue or the contaminant that has to be removed, which is in any case there, that is your residue. And we have that completely concentrated on a filter of an industrial vacuum cleaner. The overall speed is very good. More than 5 square meters an hour is really a very good cleaning speed. It's a very reliable process. The machines are very reliable and very efficient to do this. There are definitely financial advantages. I will come back to that in the next slide. And for environment as well, for man as environment, it's a way cleaner way to do this than by grid blasting or by, again, water jetting. And the health of the operators is, as I already mentioned, also a clear advantage. Now, important question when it comes to financials: what does it cost for? What does it cost, or what does it gain for the one who offers? It always depends on the application and the environment. Obviously, you can't compare it one-on-one. But the large budget is between 100 euros per square meter and 400 euros per square meter, depending on, is it a 24-hour shift? Is it in a difficult environment? Is it, all the different circumstances that you can imagine. Savings for the customer are both direct and indirect. In our references, a direct saving is up to 5 times the cost of the cleaning. 5 times. It's amazing. That's a lot of money. And indirect savings are also there. For example, we have a reference where, because of product contamination, some clients need more than 6 months for product optimization. So they butter the tank, and there is a flash rod layer that stays behind. They fill it up with their product. The flash rod contaminates that product, and they need more than 6 months for product optimization. Knowing that the unavailability of a tank in petrochemistry can cost a huge amount of money per day, then you see that this type of cleaning has an extreme lot of advantages. So to end up, and then I'm exactly at 9:45. Sorry for talking that quick, but to leave some room for questions, I thought it was necessary. Just 1 minute of commercial. Our products, we build as well mobile as stationary systems. The mobile systems go from 100 watt to 1000 watt, depending. 100 watt is, or the Gaussian lasers, air cooled, is a small laser on the bottom right corner. The bigger systems, 500 and 1000 watt, is the big system that you see in the center. And then you also have stationary system with laser heads for robotic use, and you can see them on the 19-inch rack and the robotic laser device on top of it. So I thank you very much for your attention.